Okay. So we're doing divisibility by 6. Huh? Okay. A number is divisible by 6 if you can divide it by 2 and you can divide it by 3. Must be and it must be able to divide it by 2 and by 3. Okay, so 5106. Is this divisible by 2? Yes, the last digit is even. So this number can be divided by 2. Can it be divided by 3? Add all the digits, you get 12, and 12 is a multiple of 3. Therefore, this number can be divided by 2 and can be divided by 3. Therefore, this whole number can be divided by 6. What about this number? Can you divide this by 6? Look at the last digit. Even number can divide by 2. Add all the digits together and you get 15. 15 is a multiple of 3. So this number can be divided by 2, can be divided by 3, therefore can be divided by 6. How about this number? Last digit is 2, so can be divided by 2. When we add all the digits together, you get 17. So it is not a multiple of 3. So this number can be divided by 2 but cannot be divided by 3. Therefore, this whole number cannot be divided by 6. Okay, so that is the rule for divisibility by 6. Now, divisibility by 7 is a little bit different. Okay, for divisibility by 7, we take the last digit, double it, and then subtract it from the rest of the number. Okay, for example, 2, 0, and 3. The last digit is 3. What is 3? We want to double it. What is 3 times 2? 6. So now 20 minus 6 will give you 14. Can this number divide by 7? Yes. Because this number can divide by 7, this whole number can divide by 7. 839. Look at the last digit. The last digit is 9. So 9 multiplied by 2 is 18. So the number that is remaining here is 83. So 83 minus 18 will give you 65. Can you divide 65 by 7? No, we cannot divide 65 by 7. Therefore, this number cannot be divided by 7. Okay, so let's look at one more. This number, look at the last number is 3. 3 times 2 is 6. So 447 minus 6 is 441. When you look at 441, you cannot tell straight away whether you can divide by 7 or cannot. So you continue. We have 441. Last number is 1. 1 times 2, double 1 is 2. Okay. So we have 44 minus 2 will give you 42. Now when you look at 42, you know that 42 can divide by 7. Therefore, this whole number can divide by 7. Okay. So can you understand divisibility by 7?
Yes.
Yes. Okay. Only this is a little bit different. There are just a few that's a bit more difficult. Okay. Divisibility by 8. Okay. The rule is if the last 3 digits can be divided by 8, the whole number can be divided by 8. Okay. Look at this number. Last 3 digits is 032. 32 can divide by 8. So this number can divide by 8. This number, last 3 digits. Can this last 3 digits, can you divide this by 8? Cannot. So you know this last digit cannot divide by 8. So this whole number cannot divide by 8. Okay, that's divisibility by 8. Divisibility by 9, if the sum of the digits are a multiple of 9. Okay, divisibility by 3, sum of digits are a multiple of 3. Divisibility by 9, sum of digits are a multiple of 9. Okay, so look at this number 7,686. We add all the digits, we get 27. And we know that 27 is a multiple of 9. Therefore, this number can be divided by 9. This number, add all the digits, we get 9. Also, multiple of 9 can be divided by 9. This number, we add everything, we get 19. And 19 is not a multiple of 9. So this number cannot be divided by 9. This number, add everything, we get 11. So it's not a multiple of 9, cannot be divided by 9. Okay. Okay, divisibility by 10. Okay. All you have to see is if the last digit is 0. If the last digit is 0, can divide by 10. Last digit 0, divide by 10. Last digit not 0, cannot. Not 0, cannot. Okay. Divisibility by 10, very simple rule. Okay. Divisibility by 11. Okay. Okay, divisibility by 11. If the sum of digits in the place value that are even powers of 10 minus the sum of digits in the place value that are odd powers of 10 is divisible by 11. That means I give you a small number first. Say this number 2163. This one is 10 to the power of 0, the place value. This one 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. So this place value and this place value are even number place values. Okay, 0 and 2 even number. 1 and 3 are odd number place values. Okay, so what do? We just add these two digits. This 1 and plus 3, we have 4. Okay, we have one group here, 4. And then we add these two digits, 2 and 3. The odd number, sorry, 2 and 6. 2 and 6. The odd numbers we add together. Okay, 2 and 6 is 8. So what is the difference between these two numbers? The difference, big number minus small number, difference is 4. So 4 cannot divide by 11. Because 4 cannot divide by 11, so that's why this number cannot divide by 11. Okay. So when we want to add, we can add, it's easier if we add from the back. So we can add, we add the alternate numbers. Okay. 1 plus 3 plus 9 plus 3. So 3 plus 9 plus 3 plus 1, we have 16. And then the alternate numbers, okay, 2 plus 7 plus 1. 1 plus 7 plus 2 is 10, okay. 16 and 10, the difference is 6, okay. And 6 cannot divide by 11. Therefore, this number is not divisible by 11. Can you understand that? Okay, there is another rule for divisibility of 11. Um, okay, let's try this. We subtract the last digit from a number made by the other digits. If that number is divisible by 11, then the original number is 2. Okay, let's look at this number. We take the last digit and we subtract this. So 405, 405, 02 minus 2. What do we get? What do we get here? We get 405, 405,
0 to 0.
00. Okay? Okay, this is not a very good example for me to do here. Okay. Okay, I can do this, but it's a little bit long. Let me try another example first. Okay, I'll give you another example. Let's look at this. 1,000, 14,641. 14,641. Can we divide this number by 11? Okay, so if we use another rule, we take the minus the last number. So you have 1464 minus 1. So what do you have here?
1463.
1463, correct? But we look at this number and we don't know whether we can divide by 11 or not. So we continue some more. So now the last number is 3. So we minus 3 from the remaining numbers is 146 minus 3 will give us 143. Okay, we still don't know whether this number can divide by 11. Some of you know lah. Okay, So we minus the last number again
15.
from 14. What's left is 14. 14 minus 3 is equals to 11. Now we know
11.
11 can divide by 11. Okay, 11 can divide by 11. Therefore, this number can divide by 11. Okay, so for 11, there's two rules. You can use the first rule, alternating numbers. You add alternate numbers and find the difference, or you can minus the last digit from a number made by the other digits, and you keep on repeating this until you know whether you can divide by 11 or cannot. Okay, that is divisibility by 11. Okay, then we have divisibility by 12. For 12, if the number can be divided by 3 and by 4, then it can be divided by 12. So how do we know it can divide by 3? We add all the digits together. 2 plus 8 is 18. 18 can divide by 3. So this number can divide by 3. Can it divide by 4? How do we know that we can divide by 4? We look at the last two digits. Can this divide by 4? Yes. Therefore, this whole number can divide by 12. How about this number? We add 2 plus 3 plus 5, we get 15. 15 can divide by 3. So this number can divide by 3. Can it divide by 4? Look at the last two digits. Cannot divide by 4. Therefore, this whole number cannot divide by 12. Okay, that is divisibility by 12. Now, the last one, divisibility by 13. Okay, this one a little bit more difficult. Not difficult, just we have to remember a little bit more. For any given number, to check if it's divisible by 13, we have to add 4 times the last digit. 4 times the last digit to the remaining number. We add 4 times the last digit to the remaining number, and we repeat until we get a 2-digit number. Then we check if it's divisible by 13 or not. Okay. For example, you have 2795. Okay. So the last number here is 5. 5 times 4. 4 times the last number. 5 times 4 is 20. So the remaining number is 279. So 279 plus 20 will give us 299. But we don't know whether this number can divide by 13. Just taking one look at it, we don't know. Okay. So we continue the process. We take the last number again. This last number is 9. 9 times 4 is 36. 36 plus to this 29, we get 65. Now we already got a 2-digit number, so we can see easily whether you can divide by 13 or not. So now we know that it can be divided by 13. Therefore, this whole number can be divided by 13. Okay. So for divisibility, you have to know how to check for divisibility for numbers. Divisibility 2 up to 13. Okay. Only 2 until 13. Okay. Although there are many more, but you don't have to do the rest. Okay. In summary, okay, a positive integer n is divisible by 1. 1, all numbers can divide by 1. 2 if the last digit is 2, 4, 6, 8, L, 0, 3 if the sum of the digits is a multiple of 3. 4 if the last two digits are a multiple of 4. 5 if the last digit is either 0 or 5. 6 if it's divisible by both 2 and 3. 6 is 2 times 3, so must be divided by both 2 and 3. 7 if subtracting twice the last digit of n from the remaining digit gives a multiple of 7. 8 if the last 3 digits of n are a multiple of 8. 9 if the sum of digits of n is a multiple of 9. 10 if the last digit is 0. 11 if the sum of the alternating digits, the difference is divisible by 11. And 12 if it's divisible by 3 and 4. 13 if you times 4, if the last digit times 4 added to the remaining numbers gives you a number that is divisible by 13. Okay, so you have this divisibility from 2 up to 13. We have looked at all the rules already. Okay, so why do we need to know this divisibility? to look for factors. Okay, let's look at one example. Okay, without using your calculator, can you show that the number below is an integer? How do you know if it's an integer? If you divide this and you get a whole number, if you can divide evenly without any remainder, then this number is an integer. That means you want to check if this number can be divided by 12, has the divisibility for 12. So, yes or no? What is the rule for 12?
Must be divisible by both
Divisible by 3 and
4
4.
and 3.
Yes. So, can this number, let's do the 4 first. Can this number be divided by 4? What do we look at?
68.
Yes.
Plus
Yes,
2 digits.
68. Can this divide by 4?
Yes.
Yes? Okay,
Yes.
so can be divided by 4. So now we want to check, can it be divided by 3? So add all these numbers. 1 plus 4 plus 8 plus 1 plus 4 plus 8 plus 1 plus 4 plus 6 plus 8. What do you get?
45.
45. 45 can divide by 3?
Can.
Yes. So this number can be divided by 3, can be divided by 4. Therefore, this number can be divided by 12. If it can be divided by 12, that means there's no remainder. So this number is an integer. Okay? Because we know the integers are whole numbers. Okay. So we see we have used the rule of divisibility to answer this question. Okay. That's the explanation now. Okay. Number 2. Oh, let's not do this. You do this later, okay? Okay, how do you do this? Just tell me how do you do such a long, big number, okay? How can you explain why this number is a multiple of 99? 99 is what times what?
9 times 11.
9 times 11. So if we want to find out if this number can divide by 99, what must we do?
Find out
Whether it
if
is
the number is
divisible
divisible by 11 or 9.
9.
Yes,
And
how do we know if the number is divisible by 9?
9 is by
Divisible.
sum of the digits.
Yes, we sum up all the digits. We sum up all the digits, and if it's divisible by 9, can be divided by 9. For 11,
Difference of the sum of alternating numbers.
yes, alternating numbers. We add all the alternate numbers. We have 2 groups of numbers. Look at the difference. If it can divide by 11, then it's divisible by 11. Okay, then you can try later. Okay, they have the answer here. Okay. Okay. I don't want to put this first. Okay. Okay, let's try something else. Okay, I'm giving you one number here. You tell me this number, is this number 4765? Is this number divisible by 2, 5, and 10?
No.
No, why not?
Because 6 can only be divided by 5.
Can be divided or cannot?
Can only be divided by 5.
Yes, can only be divided by 5. Cannot be divided by 2 and cannot be divided by 10. How about this number?
Can be divided by
Yes.
2, can be divided by 5, and it can be divided by 10.
Okay, good. So this number can be divided by 2, 5, and 10. Okay. Is this true or false? Do you know what this means?
9 is the factor of 5 to 8, 3.
Yes, is 9 a factor or is 9 divisible by this number? Is 9 a divisor for this number? 5283. Is it true or false? How do we do that?
Divisible.
How much is
Counting the
this?
digits.
18.
Is this 18? 18 is a multiple of 9.
Nine.
So because it is a multiple of 9, therefore this number is divisible by 9. So this is true. This statement here is true. Writing like this is true. Okay. Okay. Now list the factors. If the question is like this, list the factors for 56. Factors. List the factors of 56. How would you do that? You're supposed to list the factors. So you check one by one the divisibility rule. Is 2 a factor?
Yes.
Next,
Yeah.
3.
Yeah.
3.
Three. Better.
3 plus
No.
this 2 can
No.
divide by 3 now. 6 plus 5 is 11. 11 is not multiple 3, so no. How about 4? 56 can divide by 4?
Yes.
Yes.
Yes. 5?
No.
No. 6?
Mm,
6 means
No.
now look at 2 and 3. You know 3 cannot really, right? So 6 cannot really. 7? How do
Yes.
you do
Yes.
7?
Yes.
Because you already know that. 8?
Yes.
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 9? 9 no.
No.
Mm,
10? No.
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 11?
No.
No. 12?
Cannot.
12 means can you divide by 3?
No.
No. So no already.
No.
13?
Wait. No.
13 no. Okay. So these are the factors. So very quickly we can find the factors for a number using divisibility rule. Especially if the number is quite smaller. Okay. So this is the functions of divisibility.
Madam,
Yes.
is the factor also involve the number itself?
No.
No. Okay.
Um, Actually, by right it is lah. By right it does. But in this case, we yeah, actually it does lah. Actually, we should write. It is right to write the factor, the number itself. Okay. Okay, you do this question. Next question. Okay. 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 Do that very fast. Test divisibility for this number. That means you must tell me what numbers you can divide it by. So use the divisibility rule, okay? Not your calculators. So what is your answer? 2 can?
Can.
3?
And no,
No.
no,
4?
yes,
Yes.
5?
no,
No.
6?
no, no,
No, huh?
No.
If 3 no, then 6 also no. Okay, 7, 7? 7 can. No answer, 7. How do we define voice for 7?
subtract
Last digit times
the last
2
digit,
Times by 4, huh? Is it? Is that right? The last digit times by 4?
times 2.
the last digit times 2.
Last digit times 2, then subtract from the remaining digits.
So can divide by 7 or not?
Yes,
Still.
Can or not? Yes? How do we 7? 6 times 2, 6 times 4 is? We
Times
add or we
2.
minus?
we
We add or we minus?
we minus
Minus.
the last digit is twice and minus from the remaining.
So the last digit here is 6. So that means 4, 5, 6, 7, 8, 3, 1.
Minus
Minus 12.
6 times 2. 6 times 2.
How much
So,
is that?
4, 5, 6, 7, 8, 1,
Correct?
9.
Okay, now we minus the last digit times by 2. So we have minus from 6, 7, 8, 1 minus 18. How much is that? 45, 6, 7, 81 minus 18 is 69, correct? So it's 4, 5, 6, 7, 6 minus 18. So the number keeps on getting smaller. 4, 5, 6, 76 minus 18. Correct? Minus 8 times 2 is 16. Minus 16 is 4, 5, 65 minus 16, 9, 4. Okay? So we have 4, 5, 4 minus 18. 4, 5,
Madam,
4
this is
minus.
second line.
Second line wrong, is it?
Second line.
What's wrong here?
4, 5, 4, 5, 6, 7, 8, 1 minus 18.
81 minus 18 is how much? 67.
63.
10 minus 8 is 2, 3. 63, yeah? Okay. Lucky didn't finish the whole thing. Okay, so this one is minus 3 times 3 is 9, correct?
3 times
9.
2 is 9.
So 10 minus 9 is 1, 7,
4,
4,
6,
5,
6,
4,
6.
5, 6, 6, 7. Huh? 4, 5.
Yes.
So this is 4, 5, 6, 6 minus 14. 4, 5, 6, 6 minus 14. So this is,
4, 5, 5, 2.
yes, 4, 5, 5, 2. So 4, 5, 5 minus 2 times 2 is 4. So this is 4, 5, 1. Oh, it's slower. 4, 5 minus 2. It is
43.
43. So now you know already. Can this divide by 7?
No.
Cannot. Yeah? 43 cannot be divided by 7. Therefore, the whole number cannot be divided by 7. Okay. So 8 also cannot divide. 9 cannot. 10 cannot. So 11, 12, 13 you can do. Okay. So you got an idea on how to do this? So we finished with divisibility. Yeah. So we're going to continue. Okay. Okay, so now we finish with this. We're going on to the next topic, that is all this you can have a look at it later.